In this question, we are looking at two body systems. Once again, our two objects are connected by a rope or a string, and they are being pulled up a slope. So if we read the question carefully, it says a light, inextensible string connects two blocks A and B over here. We know A's mass is 2 kilograms. We do not know B's mass. The blocks are pulled up an inclined plane that makes an angle of 30 degrees with the horizontal by a force of magnitude F1. And I hope that you can see that we do not know what F1 is either. They give me the coefficients of kinetic friction for block A and block B. They said 0.15 and 0.45 respectively. What that means is they mentioned block A first. So the first coefficient corresponds to block A. And then they mentioned block B second. So the second coefficient of kinetic friction corresponds to block B. Our first question wants a labeled free body diagram. Then we can see a definition. And they tell me that the two blocks accelerate up the incline. So they give me acceleration and they give me tension in the rope. So it looks like they pretty much give me everything, but there are two unknowns in this question. Our first unknown is the applied force over here. That's pulling A up the slope and our mass of B. And in our last question, they want us to calculate the numerical value of M. So they want the mass of block B. So first of all, is this a Newton's first law or a Newton's second law question? You must always distinguish that in your mind. I think it's quite obvious in this one that we're dealing with a Newton's second law question because the blocks are accelerating. And not only that, they tell me to state Newton's second law of motion in words, which is a very, very big hint that we're dealing with the second law question. But our massive giveaway is the fact that the blocks are accelerating, which we know corresponds to Newton's second law of motion. Right, our first question. Draw a labeled free body diagram indicating all the forces acting on block B as it moves up the inclined plane. Now, because block B is on an inclined plane, we have to be very careful when we draw a free body diagram. So we've got a dot to represent block B. Okay, I'm going to draw my dot nice and big. Gravity always acts straight down to the ground. Always, 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 always. This is weight or gravity. So FG, or you can label it W. In previous videos, I've shown how I draw the slope in pencil to help me. So I hope you can see this little pencil that I'm drawing in. I'm going to erase it later. So you can see that the weight acts straight down. I mean, the weight would act straight down like that. So there we go, straight down. Then the normal force is always perpendicular to the surface. The surface is the slope that I've drawn in here in pencil. So the normal force will act 90 degrees or perpendicular to that surface. I hope you can see that this angle over here is more or less 90 degrees. You don't have to go and actually measure it with a protractor, but make sure that it looks more or less 90 degrees. That's my normal force, Fn, or you can label it N. Then the blocks are accelerating up the slope. So the boxes are moving up the slope, which means that friction acts in the opposite direction to the motion of the boxes. That's always how it works. So if this box is moving up, friction moves down. So friction will move down the slope, and it's always parallel to the slope. So you can see that I've drawn this along the line. That's Fk. And then, how is this box moving up the slope? Well, it's being pulled by this rope. There's a tension force in this rope. So tension, I'm drawing my tension a little bit skew. It must be in the same line as Fk. When you use a ruler, it'll be a lot easier. So that is your tension force. Okay, and that's your free body diagram. Now I can erase my slope. I've drawn it in pencil very lightly, but you can erase it. And then I just wanted to point out, this is obviously a teacher tip, and I've mentioned this one multiple times before. There are 4 marks for this question, which means you need 4 forces, 4 arrows, 4 labels. If you include any more, we will subtract marks. If you do not label your arrows, we will subtract marks. Right, our second question wants us to define or state Newton's second law of motion in words. So this is a definition that you need to know. This one pops up all the time in grade 11 and in grade 12. So there it is. I took it from exam guidelines. It's very important that you say a non-zero. So this is a phrase that they added in relatively recently into the exam guidelines, and they want you to say when a non-zero resultant or net force acts on an object. So you can choose between the words resultant or net force, but you have to say one of them. You have to say non-zero. It has to be a non-zero net force, because remember, if F net is equal to 0, that's Newton's first law. So it has to be a non-zero resultant or net force acts on an object. The object will accelerate in the direction of the force. And this next part's also important. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Please don't say indirectly proportional. We will minus marks. Okay, so 4.2 is the definition. You must just study it. 4.3 is our calculation question that is more difficult in this one. And remember, they gave me the acceleration. They gave me the tension. They want the numerical value of m. So they want me to calculate the mass of m. Now, grade 11s and 12s, if I'm asked to calculate the mass of m, I am going to attempt initially to use this box and the forces acting in this direction, in the direction of the acceleration, so up, down the slope, the parallel forces. I'm going to work out the sum of those forces and see if I can solve for m. So I know that this is an overwhelming question for some people, it's confusing for some people, but this is why my biggest advice is to always make sure you understand how to use your free body diagram, which we did over here. Here's our free body diagram. Draw another one as a rough. So let me show you what I mean by that. So here's my free body diagram that I drew for marks. Now I just drew a rough one, and what I want you to do on the rough one is break down any forces that are acting at an angle relative to the slope into components. So obviously the ones that are perpendicular, the Fn, and parallel to the slope, I can't break those down into components, but you should know that you can break the weight down into components. You should know this. This is Fg perpendicular because it's perpendicular to the slope. And this one over here is Fg parallel because it's parallel to the slope. The angle of the slope is 30, so that is that angle over there, 30 degrees. Doing this, knowing when to break down forces into components is super important. We need to break down forces acting at an angle relative to the slope into components because we need them in our F net equation. So remember, we always start off with F net equals MA. F net is a sum of the forces. In other words, forces added together. There are two directions for forces in this diagram. We have got our, what we call our parallel forces. So things that are parallel to the slope, like tension, friction, and Fg parallel. Those three are all parallel to the slope. They go in this direction. They're parallel to the slope. Okay, they go in this direction. Then we've got Fg perpendicular. And as the word says, those are perpendicular to the slope. In other words, 90 degrees to the slope. Those are Fn and Fg perpendicular. We will use these different forces, the sum of these different forces, differently depending on what we're looking for. So remember, we're looking for m. We're looking for the mass. So I was given acceleration. I was given tension. So it makes sense that because the box accelerates in the parallel direction, which is this way, up or down the slope, we are going to consider all the yellow forces in my F net equation. So this is how we start off. We say, okay, cool. F net is equal to mass times acceleration because we're doing Newton's second law, and that is Newton's second law in symbols. Then F net is the sum of all the forces in the direction that I'm focusing on. And like I said in this question, I'm focusing on the parallel direction because the box is accelerating in the parallel direction, not in the perpendicular. So we're going to add up all those forces. We've got Fg parallel plus tension plus friction. So it's all the yellow forces that I've highlighted equals MA. Now, we are looking for mass. We're looking for mass. Here's mass. We have acceleration. We have tension. We can work out Fg parallel because we know what the weight is. Well, we can work out the weight. The mass is 2 kilograms. And to work out the weight, remember we say mass times gravitational acceleration. And once I know the weight, I can use trigonometry. I will use sine to work out Fg parallel. So I'll do that in a second so we can work out Fg parallel. And friction I can also work out. Remember, friction is equal to the coefficient of friction times the normal force. And I can get the normal force. Okay? However, there's a little bit more of a complication when getting the normal force, so we'll discuss that now. But what I'm trying to show you initially is that I need to use block B. So I'm going to just write here block B. And I'm using all the forces acting parallel in the parallel direction for block B in order to calculate the mass of block B. Now, let's actually see how we fill in all these individual forces, because remember, our goal is to solve for M. M is like my X, it's my unknown in this equation that I'm trying to solve for. So let's start off simple. Let's choose a positive direction. So you need to choose if you choose up the slope as positive or down the slope as positive. It's up to you. I'm going to choose up the slope as positive. And take a look how tension is going up the slope, friction is going down the slope, so it'll be substituted in as a negative, and FG parallel is going down the slope. Remember, my slope looked like this. FG parallel is like the weight of the box, or it's a component of the weight. Which way the weight pulling this box? The weight is pulling the box down the slope. That's why this box's weight will cause it to slide down the slope. So FG parallel is going down the slope. That's very important. I know that is something that my students often get confused about. So how do we work out FG parallel? I'm going to do all these little calculations here on the side, and then I'm just going to fill them in. Okay, so FG parallel, I know that FG parallel this is your formula for FG parallel, mass times gravity times sine of your angle. You always use this for FG parallel. But why do we use this? Because FG parallel is a component of FG. How do you work out FG? Mass times gravity. So that's where the mass times gravity comes from. Why am I using sine of my angle? Because FG parallel is opposite. It's opposite my angle, so I use sine. Okay, so it's fine if you memorize it and you know, like, okay, cool, if I'm looking for FG parallel, it's mass times gravity times sine theta, but it's good for you to understand why. So the mass of the box is, we don't know. We are looking for the mass of the box, but that's okay because M is my unknown. That's what I'm solving for. So I'm going to have an M over here that I don't know, and I'm going to have an M over here in this term that I don't know, but that's okay. You'll see how it works out. G is gravitational acceleration. It is 9.8, and sine theta is sine or sin of 30 because the angle's 30. So FG parallel, that is my FG parallel. And I know that there's an M in there, and I know that we can't work out what this is yet, but it's okay. We're going to substitute that into our equation. But which way is FG parallel going? It's going down the slope. So it must be substituted in as a negative. So it's going to be negative M 9.8 sine 30. Great. So we've done one of them. We've done FG parallel. Tension is nice and easy. They give me the tension in the question. So they say the tension in the string joining the two blocks is 18 Newton. Fabulous. 18 Newton. Tension is going up the slope. We chose up as our positive direction, so tension is plus 18. Now, friction is a little bit more tricky. And I'm probably going to need a little bit more space eventually over here. So what I'm going to do is I'm going to do that, just because I know that it's not going to fit in over here. How do I work out friction? You should know that friction, the formula for friction is the coefficient of kinetic friction multiplied by the normal force. Now, I know the coefficient of kinetic friction. They gave it to me in my question. They said the coefficient of kinetic friction for block B is 0.45. Okay, so they gave me block A and block B. 0.45 is the one that I care about because I'm working with block B. So I know this coefficient of kinetic friction is 0.45. However, I do not know the normal force acting on the block. And I have done videos on normal forces and how to find the normal force. So if what I'm going to say now is confusing, you can click the playlist linked in the description, and I do go over this. But in the case of this object, the object is on a slope. So take a look at your free body diagram once again. You can see here that the normal force and FG perpendicular, those two forces are acting perpendicularly to the slope. So technically, Fn and FG perpendicular must add up to 0. And this is also confusing to my students. They say, ma'am, why must it add up to 0? Because the box is not moving in the perpendicular direction. It's not accelerating or moving in the up-down direction. So what that means, grade 11s and grade 12s, is that Fn is technically equal to FG perpendicular. but they're equal in magnitude, which is why I said technically. So if I know FG perpendicular, that is the same as my normal force. So what I'm going to do for normal force, and you can make a note here in your book or whatever you used to study, that the normal force is the same magnitude as FG perpendicular in this question. Remember, it won't always be the same in all questions, because if there's another force acting in the up-down direction, then it won't be Fn equals to Fg perpendicular. It'll be the sum of those three will equal to 0, but I've done that in other videos. So for this question, it is true that Fn and Fg perpendicular are the same magnitude. That's what I wrote there, magnitude. Okay, so if I can find Fg perpendicular, then I've got the normal force. But how do I find Fg perpendicular? Remember over here I found Fg parallel. Fg perpendicular is very similar. It's mass times gravitational acceleration times cos of my angle. So my mass I do not know. My gravitational acceleration is 9.8 and cos of 30. So this over here is Fg perpendicular. This over here, mass times 9.8 times cos 30. I know I don't know mass, but that's okay. That is what I'm going to substitute in the place for n, because the normal force is the same magnitude as Fg perpendicular. I hope you're with me. So I'm going to go mass times 9.8 times cos 30. I know that looks crazy, that looks like a mess, but that is exactly what I need to substitute in. This whole thing is friction. Friction is equal to this entire thing. So this entire thing must go in there. And again, ask yourself, which direction is friction going? It's going down the slope, so it must go in as a negative. So I hope you can see now why I said I don't have enough space. So negative 0.45 times m times 9.8 times cos 30 equals my mass I do not know, and my acceleration was given in the question. There it is. And it accelerates up the slope, so it must be a positive acceleration, 5.72. Now I know that that looks overwhelming and it looks like, oh my word, what are we not even answering the question? But we are. Remember, the question asked us to solve for m. And look at our equation that we just set up. There is only one unknown. There is only one unknown. Okay, so let's see if we can solve this. So what I would do first is take each term and try and simplify it. So try and simplify that by saying 9.8 times sine 30. So I'm going to get negative m 4.9. You can always write that as negative 4.9 m. It's the same thing. So I'm going to write it as negative 4.9 m because it just seems a little bit better. Negative 4.9 m, it's the same thing. So I just multiplied 9.8 by sine 30 to get negative 4.9. Then we've got plus 18. That's my next term. I can't simplify that. Then my next term is going to be a negative because there's my negative. I'm going to say 0.45 times 9.8 times cos 30. And I get quite a long number. So it's 3,819172. 3 6 decimal places is enough. M, because remember there's an m there. There's a variable there. So you can't just throw it away. So how I got this number is I times 0.45, 9.8 and cos 30. Then you drop the m over there. Then equals 5.72 m. Okay, cool. Now, why didn't I round off here? Remember, this is a massive teacher tip. In physical sciences, in physics and chemistry, we can only round off at the end of a question, and we're not at the end of a question. Now what we do is what we always do in maths, and that is we group or gather our like terms together. So what I mean by that is I'm going to keep 18 on this side because it's the only thing that does not have an m, and everything with an m I'm going to take over to the other side. Okay, so that stays here. Positive 4.9 m, positive 3.819172 m. These are like terms, all these m's, so I'm going to add them together. And I get 14.43 m, don't round off. And then to get m alone, this is times m. So to get m alone, I must say 18 divided by 14, whatever, that whole number. And you should get 1.2466. We can round that off. 1.25 kilograms. Remember, we're looking for a mass. I just want to show you where you would get your marks for this question, and I hope that this question makes sense. So you would get a mark for your equation, so stating all the sum of your forces over here. Then you would get a mark for this term over here because you had to do some thinking over here. You'd get a mark for this term over here. You'd get a substitution mark for substituting in your acceleration over here. And then you would get your final answer mark. So 1, 2, 3, 4, 5. I hope that this video has been helpful for two-body systems. I do have more videos on two-body systems, one-body systems, all these sorts of Newton's first and second law questions. So remember to check out the links in the description box below for more videos. I can't wait to see you in the next video, and I hope that you've subscribed. See you, everyone.